Hello, good morning everyone. My name is Mark Staples from Euchner. I'm going to give you a presentation today on how automation safety is revolutionizing industry, in particular with logistics centers, intelligent logistics centers. So I'm going to start with the agenda. And the main heart of this manufacturing and distribution safety is an electronic RFID key. So I'm going to talk us through how that works and the different applications that we can use that for. So as an authorization system, as a lockout system, key transfer, but more importantly, around a case study on a crane access system. So what is an electronic key and how does the system work? Well, fundamentally, it's made up of two main parts. We have an electronic key or transponder, which has a code on it. It's RFID, so it uses radio frequency to communicate to and from the reader. And the key reader is the fixed part, which is located in either the locking module or on the machine. And that's where we put the key in and pull the key out to initiate a sequence. Okay, so they're the two key parts. You've got a reader, which reads the chip. It recognizes the chip, and if it's the right chip, it will allow you to proceed. And then you've got the key itself. The keys are batteryless, so they use RFID, so it induces and powers the chip up, and then the chip talks to the reader. So it's a battery-free environment. So you can use they also use high-level security RFID. So what that means is for a safety application, you can't get into it, tamper with the frequency, the coding. It's all locked down because it's part of a safety function on that machine. So it's been designed that way so that it does a specific task. So the applications that we can use this for are authorization, lockout, a digital key transfer system, and we'll talk about the benefits of that, and also key in pocket. So the key is on the operator when they go into hazardous areas or hazardous, dangerous parts of the machine or the cell. Some of the drivers around this are the key legislation in the UK, which is the Supply Machine Safety Regulations. That's a legal requirement in the UK that we need to satisfy the essential health and safety requirements of that. And to help us do that, we have standards. And some of those standards are a key driver or an influencer with the use of this technology now. So 14119 being the interlocking, 14118 is inadvertent startup of machines. It's a real key benefit for addressing that issue. And it links nicely into 13849 and some of the updates around that standard. It's also part of the pure provision and use of work equipment regulations for mode selection. So it does link into that as well. So when we're using our work equipment, it offers a benefit there as well. So if we just have a quick look at some of the applications. So as an authorization system, we could have a master key. We pull that master key. That RFID key is on the person then, but that through our automation can authorize other parts of that cell or other parts of zones that we want to go into. So the benefits there is that you've got a simple authorization. You can have different keys for different parts of the cell. They can be in different colors if you need to. And if you lose them, it's a very simple teaching facility. I say simple, you need to go into the software and it's a deliberate action to reteach a new code, but the previous key is forgotten, okay? And you can program, if you want to, several read keys, okay? So you might want more than one key to be in existence. So as an authorization system, it's very flexible, and it can form part of a key transfer system. So as a lockout system, we have a main key, which we use in conjunction with maybe lockout, tagout regimes on site. It's directly teached into a specific key reader. If you lose that, you can quickly and easily program another key because it's electronic. We can do that through the reader. There's a little button on the back to do a teach facility. There's a specific procedure to do that, which makes it a bit more robust. But we can then start integrating that into our lockout, tagout regimes on site and using it as part of a safety function. So it does complement existing lockout, tagout procedures that are in place on the site, so with traditional padlocks. Now, another interesting thing, or a real interesting thing, which is where the in logistics centres or intralogistics centres, it's a real plus, is that we can now start using it as an electronic key transfer system. So there are traditional mechanical-based key transfer systems on the market, very robust, very reliable, tried and tested. With an electronic RFID, we can have more than one reader in existence. So we can have a master reader, which is either on the outside of the cell. So to gain access, we would remove the token or the fob. That's now on me as a person. I can enable or allow access to the cell. That could be after a period of time to allow residual energies to come to a standstill, or through a deliberate process of I want to press a request to enter button. But once we're inside that cell, I've got the key on me, this electronic key. I either put it in my pocket, clip it to my belt clip, but then I can transfer it to a second reader inside the cell. Now that second reader can either go back to a traditional safety-related control system with hard wiring, or it can sit on a safety bus network, which is the real drive, and that's the real motivation for logistics centres to look at this because of the safety PLC aspect. But what that second reader means is that I can then, through the automation, set up specific safe operating procedures, jog functions, slow speed. I can clamp variable speed drives or motion to work at a very creep speed, so I'm in control of the hazard. The other benefit is if somebody walks by, doesn't see me, and inadvertently closes the door on the cell, they can't lock it, they can't start the machine because the main reader is inside the cell. So it does have a lot of benefits when we're looking at an electronic key transfer system. Okay, and through the automation, we can track the key so we know where that key is. So we've got many applications. We're going to be talking about, in particular, why this is so popular for a crane access system or intelligent logistics centres. So the benefits really for this type of application is that we don't necessarily need those traditional mechanical-based key exchange systems. Some of them use not a kind of traditional key transfer, but maybe a RONIS type key as part of that key access, which gets abused. You can easily copy a simple key. It's a bit more difficult with a trap kind of key technology. I get that, but it's open to manipulation and it's open to a procedure. So we can negate the need for that. It's in an electronic environment now. We can do one key, can have many functions associated with it, such as key transfer. And each guard door and associated aisles can be accessed with a single key. So there's a standard EN 528 for aisle cranes that has a specific requirement about the access requests, the need to lock the door behind, put the key into a crane, do the manipulation of the crane in an aisle safely. So we can use that automation to configure that system really quickly and simply. So that leads me into a case study, and this is based around a logistics center. So this is an aisle crane solution. So this is our online shopping world. So huge logistics centers, lots of racks, aisles, different products being picked and placed, put into totes, sent on a wagon, and they arrive at our doorstep. To access these systems, these cranes travel really fast up and down these aisles. It's all automated. There's a heavy amount of automation layer in there at the moment. So some of the customer challenges around the mechanical-based systems is that we have a key, a simple key, and that key gets passed from person to person. It can be manipulated fairly easily. So there's lots of downsides there to duplicating those keys to gain access to a very high-risk area. We can have lost or stolen keys. So if we lose a key, we have to have another one cut, or we have to have another one made. That can take a day, several days. So it does have an increase on the downtime. And if you're a 24/7 logistics center, you need to have your crane aisle up and the downtime reduced. And also, you've got no control of the key. You're relying upon a mechanical process. You're relying upon an operating procedure to transfer that key and make sure the key goes back and the key box is locked, which can be open to misuse. And it doesn't integrate very well into a modern control system. As you can appreciate, these logistics centres are huge. Many aisles, many locations, many pick locations. The automation layer that's managing that, if you're trying to introduce a mechanical-based system, it doesn't really lend itself that well. And there's also, we've been told, a pretty slow response to emergency situations because the key could be lost. Who's got the key? Type scenarios. So there's a picture there of kind of the existing system, which has got the key box. You open the key, you release a key, and then you unlock the door and you can enter the aisle. And then they've got another key on the crane, which you start the crane up and do the manipulation of moving a box that's fallen over or whatever jam you need to unjam. So the solution was they use an automation platform. It's a safety automation platform. So all of the safety functions in that main controller are all fail-safe, secure. So this sits on that safety bus network via the comms module. So the old mechanical lock was replaced with an electronic guard locking system. Being electronics, longer life, you get less wear. You're using the safety PLC to do the shutdown. So there's a reduced wiring because there is only an Ethernet cable going back to the main control system. So from an installation point of view, there's no multi-core cables or heavy-duty cable containment shipping that around to the main control panel. So there's a reduced wiring, but also the integration of that is a lot quicker and easier. We also get real-time data and diagnostics. Okay, so we know when a request has been made. We know why a request has been made because there's a jam. We can access that aisle safely. There's local stop buttons on there. So if we see an emergency situation, we can hit the stop button. That's all over that safety bus network. But more importantly, we can introduce the RFID key as part of that safety function. Okay, so this particular system, the EN528 standard, describes that you should enter the aisle and you should lock it behind you. So on the back of the locking module or the handle module is a specific lock that locks behind, but it will only lock when the key is removed. So I'm in the aisle, I'm in the hazardous area, I've taken my RFID key from my main access point, the guard is locked behind me so no one else can pass through. At that point, there is open to manipulation because two people could go through in theory, but again, there's procedures in place wherever you go for stopping things like that happening. But I've got the key and I then transfer that into a second reader, which is on the crane. So I'm right in the hazardous area. So I get real-time diagnostics of that. My automation knows that the main key has been pulled, so it assumes entry to the cell. It's individually coded, those keys. So there is I could track that through my system to make sure that they're not being accessed far too frequently, because there might be a mechanical issue with the aisle crane that we need to address. And if we do lose that key, drop it down the gutter or the drain system that's in these logistics centres, we can easily and quickly program a new RFID key through the automation layer. For the crane access, so we've already made the request to enter that particular aisle. We've pulled our RFID key out of its reader. We've unlocked the door. We've entered the area. We've closed and locked the door behind us so no one else can follow me in. I then transfer that key into two parts of the system. Okay, so there's two readers, one on the front and one that enables joystick controls. So if a product's fallen over in my huge logistic center aisle, I can move the crane to go and locate it. I'm not climbing over racking, putting myself at risk. I'm using the crane itself to do that. If I need to go in and lift things out of the way, that's when I transfer my key to the main control station, and that stops any of the crane local movements. That disables that function. So we've got two readers. It's safe and secure because there's operating procedures in place. The automation layer knows where that key is, so it's traceable. There's no risk of inadvertent startup. So to get the whole system to start at full speed, I need that key in the main reader, which is outside of the cell. Okay, so it will not start. I can't get another key to make it start. So I'm inside the hazardous area. And I can have reduced operator risk due to me having that clamp speed and that safe operating procedure for moving the oil crane safely. Okay, these things travel at breakneck speed. I've seen one go from standstill to the top of the rack and it's like lightning, so I wouldn't like to be in the oil crane when that takes off. And it's simple integration to the existing automation control system. Most companies now are looking towards using more automation because they want the diagnostics, the data. Logistics centers are a data-hungry engine. There's lots of data whizzing around, different products, different aisle locations, different picking times. So it really nicely attaches itself to that automation layer. Thank you for your time and attention. If you've got any questions, come and see us at our stand. But thank you for your attention.